Hey 7th graders, it's Mrs. Tremblay. We are now starting Chapter 2. Chapter 2 is the longest chapter. It only looks like a few sections in your book, but there is so much to it. So a lot of the sections that you're learning about, I have broken up into a few different parts because I think if you did it all at once, it might be a little too much. So 2.1a, there's actually an A, a B, and a C. And today's focus on Part A is just to focus on rational numbers and all some vocabulary words that go along with that. So what is a rational number? It's a number that can be written as a ratio. A ratio is just a comparison of two numbers, and there's several ways to write it. We'll talk a lot about that in Chapter 3, but basically there's a number in the numerator spot, a number in the denominator spot, and A and B need to both be integers, so positive or negative whole numbers, and B can't equal 0 because you can't divide by 0, right? Thou shalt not divide by 0. The examples below are all rational numbers because we can write them as a ratio of two integers where the denominator is not 0. So when you look at numbers immediately, if you see, hey, that's not a fraction, that's not a ratio, that must not be rational, you have to actually look at it and say, could I write it as a ratio, though, where A and B are integers? So when you look at the number 2, I know the number 2 isn't a fraction, but 2 over 1 is. And those have the same exact value. So because I can write 2 as a ratio, and the denominator's not 0, and 2 and 1 are both integers, it's good. Same thing here, negative 3, I can write that as a negative 3 over 1. So that's a rational number. Now this says negative 1/2. I can write this as a negative 1 over a 2 or 1 over negative 2. That's also a rational number. And in looking at this, 25 hundredths, we think, well, that's a decimal. That's not a fraction. That's not a ratio. But in our decimal equivalencies, we know that 25 hundredths is equivalent to 1/4. So this can be written as a fraction. Or maybe you were thinking 25 over 100, which simplifies to 1/4. So all of those numbers are rational numbers. And yes, I'll be giving you some numbers and I'll ask you, is this rational or not? And you'll have to be able to say yes or no. So that's part 1. Terminating and repeating decimals are also rational numbers too, because they can be written as ratios where A and B are integers. What is a terminating decimal, you say? It's a decimal that ends. It terminates. It ends like the Terminator stops everything. So examples like 1.5, negative 25 hundredths, 10.625, those are just plain old decimals. There aren't any dots, there aren't any bars over the top, they just end. Those are terminating decimals. All of these can be written as fractions. This is 5/10ths, this is 25 hundredths, this is 625 thousandths. 625 thousandths means 625 over 1,000. 25 hundredths means 25 over 100, which are fractions. So basically decimals can all be written as ratios. A repeating decimal is a decimal that has a pattern that repeats, like negative 1.333, and then there are these little dots after to show you that it keeps going on and on, like me. I know, I do it all the time. And here we have 0.15, 15, 15, 15, dot, dot, dot. That means it's going to keep going. So instead of making those dots and writing the digits a bunch of times, all we do is put a bar over the digits that repeat. So instead of writing negative 1.333 dot, 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 we're going to put a bar over the digit that repeats to show whoever's looking at this that, yeah, this is a repeating decimal, not terminating. Terminating decimals aren't going to have that bar over the top or the little dots. Instead of writing this all out with the dots, you can just put a bar over the 1 and the 5 because the 1 and the 5 are repeating. So you can't just put it over the 1, you can't just put it over the 5, you have to put it over both of them. Okay, so the kind of key idea, I want you to be able to distinguish between whole numbers, integers, rational numbers. We've kind of built all of this up now from some of your prior background knowledge. So remember back, what are whole numbers? They're positive whole numbers, so no fractions or decimals, and it does include 0. So when you're looking at the whole number section of this, inside the whole number bubble, I would include 0, and we're talking about numbers like 1, 2, 3, and I'll put some dots to show that it goes on and on. There aren't any negatives in here, but 0 does count. 0 gets included with that. When you think about integers, we learned that integers are positive or negative whole numbers, including 0. So integers, that's going to include the whole numbers, right? Those are all integers as well. So that's why this circle is within this circle, because this is going to include that. Integers also include numbers like -1, -2, -3, and so on and so forth. So we have positive and negative whole numbers, and because this circle is within this circle, that means they're included. As far as rational numbers go, they're any number that can be written as a ratio of two integers where the denominator is not 0. So rational numbers are going to include integers and whole numbers. All of these, if you put a 1 under them, can be written as ratios, right? So some other numbers that I couldn't include in the integers or the whole numbers that are only rational numbers would be like 2/3. 2/3 is not an integer and it's not a whole number. All right, and then let's see here. What about like 1.5? That could be included. Or 8.67, or maybe a repeating one. Let's make it negative, -1.3, repeating. So all of those are only rational numbers. So if you have a whole number is an integer and a rational number. If you have an integer, a negative integer is only going to be an integer and a rational number. And if you have a fraction, it's only going to be rational. So it's kind of like working its way from the inside out. All right, sound good? Let's move on. Next page. Tell whether the decimal is terminating or repeating. So now we're going to kind of apply what we have just learned about, and that best happens with examples. So all I need you to do is look at these 4 and tell me, are these decimals terminating or are they repeating? And this is mainly so that when decimals repeat, because in our next section you're going to have some that do and you're going to be writing them out yourself, I want you to be able to properly note that. So when you look at this first one, I see 2, 4, 2, 4, and I see those 3 dots. Those dots afterwards show me that this pattern is going to continue on and on and on. That means it doesn't stop. Those dots mean it keeps on going, so this would be repeating. Next, I have -0.232. Now we might guess that, oh, the next digit's 3, and then 2, 3, 2. It looks like there might be a pattern, but there aren't any dots, and there aren't any bars over the top of any of these. It just stops. When it just stops, that means it's terminating. Okay, same here. I know I see 12.12, and we could assume that it's 121212, but there aren't any dots and there aren't any bars. When there aren't any dots and there aren't any bars, it means it stops. So this one's also terminating. And this last one, it's -2.436, and I have a bar over the 36. That means that this is going to keep going, 36, 36, 36, 36. So when you see the bar, when you see the dots, that means repeating. Okay, last little part here. Tell whether the number belongs to each of the following number sets: rational numbers, integers, and or whole numbers. So remember that numbers can fall into more than one category, right? So we want to list all the categories that this number could be included in. So let's start with -6. For -6, first off, -6 is a whole number. Yep, but it's negative. And whole numbers are only 0, 1, 2, 3, 4, only positive. So it's not a whole number. Integers are positive or negative whole numbers, so I know this number is an integer. And could I write this as a fraction? Yeah, you could put a 1 underneath it. So that means that this is a rational number as well. So the number -6 falls into 2 categories. And the next one I have -4 and 1600ths. First off, this is not a whole number. It's a decimal, right? So it doesn't fall into the whole number category, and even though it has a negative sign, it's not an integer either, because integers need to be whole numbers. But could I write this as a fraction? I sure could. -4 and 1600ths means -4 and 16 over 100. And if I needed to change that to have a single numerator and a denominator, we know the half cloud ma. We know how to change mixed numbers into improper. So that would make this a rational number. Only. If it's not a whole number, it doesn't fit into any of those categories. And finally, we have the number 10. If we're starting kind of from the inside out of our chart, whole numbers are positive whole numbers including 0. So this is definitely a whole number. Integers are positive or negative whole numbers, so that's also an integer. And I could put a 1 underneath that to write it as a ratio, so that means it's also a rational number. And believe it or not, you are done for today. See you tomorrow.